The next presentation will be done by Vyacheslav Lobzenev. He comes from the Innovation Technology Centers of Russia.
Good day, dear colleagues. Let me welcome you to this conference and express words of gratitude to the organizers and Viktor Nikolaevich in particular for this outstanding and stellar performance in organizing this great conference. I represent the Innovation Technology Center. This is our first time here, so let me introduce you to what we do in remote sensing. We have ample experience in handling space imagery, and today I will focus on Russian satellites and the quality they can produce. We have our own in-house software that we have been designing and developing for roughly 10 years. This is a commercial proprietary product now. It includes image processing from Canopus and Resource P and BK satellite. You can do tasking and do thematic processing with clustering, classification, textual analysis, and the formation of the so-called GIS projects, which we can deliver to customers automatically based on stitched strips. Since we're talking about massive materials, today the question was raised by the amount of data collected by satellites. Indeed, only 10% of the data collected by satellites undergoes qualitative processing. This is bulk of data that is hard to digest. Having realized the complexity of the problem, we developed our algorithm that allows fully automatic processing of data based on spaceborne imagery every day. Our modest capabilities enable processing of 100,000 square kilometers. We've now encountered a challenge. It's not so difficult to process data, but rather how much it takes to verify, to check quality of data. It takes longer than all the previous processing sessions all rolled into one. So this is the interface that accommodates all the features I mentioned. It comprises all types of data: vector, raster. Why is it called image video center? That's because heterogeneous data is accommodated within one single environment. So this is an image from Canopus V. The root strip goes through all stages of processing. Resolution here is 2.5 meters in pan and 10 to 15 meters in multispectral mode, typically. Then we stitch images, apply radiometric correction individually, depending on the scene, seamless stitching, refining georeferencing, decreasing noise, and increasing detail. The results of processing are a multispectral, stitched, nice-looking RGB composite, plus the passport and the attributes with the root itself. This is how the stitching takes place. I would like to note that we can have quite long strips, quite heavy. This one in Huggins takes up about 300 gigabytes. And let me share with you a couple of nice pictures showing the quality domestic satellites can produce. This is the Emirates, China. A very indicative picture which shows you that the stitching of heterogeneous micro images is done in a seamless way, and there are no traces or artifacts. This is Cuba. Advantages or benefits of Canopus data processing is it is fully automated. And at the end, you obtain the image in the form of product that I mentioned earlier. It is brought down to 2-meter resolution and in pen and multispectral to 10 meters. Noise level decreases, and then thematic processing takes place by multispectral channels. This is the example of completed project. We calibrated Canopus V through cross calibration, and now we can perform thematic processing. In this example, you see classification of various types of vegetation. You can look for damaged, drying trees. Well, this is in Arhardix for water resources. For detailed analysis, we plug in external services. It could be standard WMS or WFS. With this we can do modeling given specific or future meteorological conditions. Resource P is a solid, good satellite that shows us images from space. In this case, we developed the work flow to stitch images. I will not list technical characteristics. Potentially, these materials can be handled in a more profound way, delivering more detailed result. You can do radiometric correction, georeferencing. If you compare subimages on the left and right, there is a 10 to 15% better resolution. This is another panchromatic image. In this case, it's 15 to 20% better, thanks to the knowledge about image generation. This is how our software processes geotone products. And this is one of the earlier products we handled before. We closely work or collaborate with our operator MZ, and all the materials are provided to Roscosmos, Russian Space Agency. This is Sweden. What are the advantages? The entire process is automated. One person can handle up to 10 to 20 workstations and deliver 10 to 20 routes every day. The only problem is that given massive performance capabilities of the complex, it takes a lot of time to verify and validate the results. Even though now we started to think how to automate the verification process itself, because there's a lot of material coming out, and once the images have been stitched together and you obtain multispectral image, we do thematic processing based on different classification methods. In this case, we did the broad-leaved tree classification. We also have 120 meter wide swath capture capability from the satellite. Our software uses thematic processing of hyperspectral data from resource P. Based on different classification methods, knowledge of spectral characteristics, you can perform various types of processing and data classification. This is an example of using hyperspectral features to classify the underlying surface and water surface. I mean, we can even measure depths. The software has a range of functionalities as a GIS. This is one of the projects where we simulated and developed solutions to build corridors, clearings, etc. This is another project showing how spatial data can be matched with vector information. You can calculate how much forest needs to be chopped if tree plantations need to be removed and what damage will be like. And for training purposes, our software complex allows using classifiers known to scientists, but also to make it look less scientific, less rigorous. School children can use some maps to make the training process fun. This is a screenshot of one of our customers. This is how they customize the map for themselves. The image center continually develops. It is updated at least about once a month. We switched to 4-bit version this year, We support all data from resource P. We increase production capabilities, even though it is as high as it is. The volume of vector data can reach dozens and hundreds of gigabytes in one layer. Another benefit is that it is totally Russian product. It allows merging all types of data and processing in one environment. You can work with databases of spatial data. It has its own algorithms and processing which do not require technical competences. I mean, it's quite easy to piece together the required tools out of cubes. Thank you for your attention. Are there any questions? No questions. Okay.